Okay, so finally, we're going to talk about the Cisco Unified Computing System. Everything I've talked about so far has all led up to this. So, first let's start out with what this looks like as far as physically. What I have here is I have two chassis. I have a 6U chassis here. I have another 6U chassis here. I've got some fabric interconnects, much like the fabric interconnect that was defined here in this section. So we're going to talk about 10 gig and the unified fabric, all of that's going to play in. And in these chassis I have some number of blades. In this chassis I have 8 blades, these are half-width blades. In this chassis I have 7 blades. I decided I'd put in 1, 2, 3, 4, 5, 6 half-width blades and 1 full-width blade. So you can mix and match half-width blades and full-width blades. The full-width blades give you extreme memory density that I'll get into later. So first let's start out with, again, the same message. What does an ESX server consume? Here I have an ESX blade. It's got network cards and it's got fiber channel cards. What we're really doing is taking this concept of a CNA and creating a new type of CNA called a virtual interface card. So remember the concept of the CNA? Think of the CNA on steroids in these blades. So 10 gig cards that really just have 2 ports coming out of them, but can represent to the underlying ESX operating system, make it look like as many NICs as you want it to. So thinking of taking a 10 gig NIC and chopping it into as many pieces as you need, and chopping out of that some fiber channel over Ethernet as well. So really out of this, there's really only 2 ports that come out of this. One here to the backplane, one over here to the backplane. But to the operating system, it can show itself as many NICs, and you've got 10 gigs of throughput. The chassis itself connects up to the fabric interconnect. Remember the concept here of fabric extenders and a fabric interconnect and how it was like a master-slave and this was the master and you just had to manage one? It's that same concept here. So none of this complexity of spanning tree or having to worry about loops or lots of designs. A real simple design that's super fast, no loops. So basically, I connect this fabric extender up to this fabric interconnect. I connect this fabric extender up to this fabric interconnect. And everything goes across that cable, both fiber channel and Ethernet. And if I want more bandwidth to my chassis, I just connect more. All 40 gigs of throughput on this side, 1, 2, 3, 4, 40 gigs of throughput on this side, 80 gigs of throughput to this chassis. I've got 8 cables coming out of it, and I manage it all from this fabric interconnect. And it's so easy for me to add a new chassis. Here I was adding chassis in 4 days. Now I'm adding a new chassis in an hour with no designing, no design time. This one fabric interconnect can support up to 14 chassis. 14 times 8 is some really big number. I'm not going to do the math. That's a lot of servers that can be managed by one set of fabric interconnects. I'll get into the management in a minute, but it's really, really impressive. So far, you see how simple this is? Remember how in this environment we wanted to segregate our vMotion and our fault tolerance and our service console and our virtual machine network? Now I can do that because to the ESX host I can represent as many physical NICs, however they're virtualized in a fancy way here back behind the scenes. But ESX sees that as 8 physical NICs. I can make this server look like 4 physical NICs if I want to, but I'd probably just make them all the same. Now what else does the ESX server consume? It consumes SAN, right? So there's actually, I really don't need to draw any more connections because think of the converged network adapter. I've already made that connection, but now through fiber channel over Ethernet, it's riding over that same link. And there's actually connections here. This connects to your traditional SAN fabric. The fabric interconnects will then connect to your traditional aggregation layer or core layer. Everything's connected just through those 4 simple cables out of the fabric extenders. So it's really, really simple, super, super fast, high density ESX host that can hold lots and lots of VMs. The fastest vMark performance on the market right now was given, like the fastest, highest score was given from a blade in a UCS chassis. So it's really, really exciting. These blades can hold 96 gigs of RAM. These blades can hold 384 gigs of RAM. And again, like I said, the only solution on the market that can give you such a flexible 10 gig NIC. It's a special conversion network adapter that's only provided by Cisco. And 384 gigs of RAM, no other blade on the market, almost no other server on the market, where you can put that much memory into one blade. So that's really exciting. Again, that's a Cisco solution that allows them to do that. So what I've shown here is a really simple way to grow out the environment, without that 4 days of planning time. If we talk about time consumption, the initial implementation of this, configuring this into your network, into your SAN, is really quite simple. These will be 10 gig connections. These will be 4 gig connections. The initial time, once you've done all your planning, you can do your initial design in 1 day, get your first chassis connected. Your next chassis is going to be about 1 hour. And then blades from that point forward, 30 minutes or less. And guess what? This solution is really the only solution on the market that was purpose-built for boot from SAN. And what do I mean by that? Well, remember here I was talking about how these network cards had built-in MAC addresses that were burned in, and these HBAs had burned in worldwide names? These blades don't. They actually receive their worldwide names and their MAC addresses and their BIOS settings and many, many other settings from the master. And there's something called a service profile. And this blade is configured with a particular service profile. So I can actually pull this blade out, put in a replacement, assign that service profile, immediately boot from SAN, I'm up and running. I can move that service profile anywhere in any chassis, up to 14 chassis in one management interface. Top of that, let's get into cost. Cost. This is probably, of the solutions I have on the board, of the first three, this might be one of the least expensive. This solution is probably the most easiest to manage and scale. This would be the most expensive solution, and out of everything, at scale, this is the least expensive solution on the board. It's the fastest, highest performing, easiest to manage, and least expensive solution at scale. Just in acquisition costs. I'm not even talking about management. So we're talking about time. The consumption of time is less for your people, faster to provision. Consumption of network is way less because fabric interconnects can now hold up to 14 chassis. So you're not going to be extending out your aggregation layer, your access layer, or your core as frequently as any of these other solutions. It's quick to add new chassis. Chassis are now less expensive, where chassis here might be $55K. These chassis are roughly $8K. So a lot easier to consume new chassis, and you don't have to worry about being the guy that has to pay for the 9th server. These are very consumable. There's not SAN switches in here. There's not more Ethernet switches in here. There's fabric extenders. You do not have to manage these switches. It's just plug and play. It plugs right into the fabric interconnect. It's an extremely simple model, extremely capable, very high performance. I can't say enough about Cisco UCS. I told you it was built for VMware. You can provide as many NICs to the ESX operating system as you want. You can provide as many HBAs to the ESX operating system as you want, or just a straight Windows operating system. It's not just for ESX, but it's very powerful as an ESX, for an ESX environment. So as you can see, I'm super excited about Cisco UCS. I hope I've covered everything. Thanks again for your time. I really appreciate it.